Hello everyone! Ever wondered how scientists measure the concentration of a substance in a clear solution? One of the most common ways is using a technique called UV-Vis spectroscopy. Today, we're going to break down exactly how you can calculate concentration from the data you get from a spectrophotometer. It all comes down to a simple but powerful rule called the Beer-Lambert Law. The Beer-Lambert Law is an equation that looks like this: E equals epsilon BC. Let's quickly define these terms. A is for absorbance, a unitless value the machine gives you that tells you how much light your sample absorbed. Epsilon is the molar absorptivity, a constant unique for every substance at a specific wavelength, essentially measuring how well it absorbs light. B is the path length, which is the width of the cuvette holding your sample. For most experiments, this is exactly 1 centimeter, which simplifies our math. Finally, C is for concentration, and that's the value we want to find. The most accurate way to use this law is by creating a calibration curve. Here's how you do it. First, you prepare a series of standard solutions, which are samples with precisely known concentrations. Second, you measure the absorbance of each of these standards using the spectrophotometer at a specific wavelength called the λmax, where the substance absorbs light most strongly. Third, you plot this data on a graph with absorbance on the vertical y-axis and concentration on the horizontal x-axis. This plot should form a straight line, and you can get the equation for this line, which will be in the format y equals mx plus b. Now, to find the concentration of your unknown sample, you simply measure its absorbance using the same settings. You can then use the equation of your line to calculate the concentration. Just plug the absorbance of your unknown in 4y and solve for x, which is your concentration. The formula becomes concentration equals absorbance y-intercept / slope. While the calibration curve is the best method, there is a shortcut. If you know the molar absorptivity, epsilon, for your compound from a reliable source, you can rearrange the Beer-Lambert law to directly calculate concentration, C equals a / epsilon, assuming the path length is 1 centimeter. However, this is often less accurate, which is why the calibration curve method is preferred. And that's really all there is to it. By creating a calibration curve, you can confidently determine the concentration of your unknown sample. Thank you so much for watching. If you learned something today, please consider giving this video a thumbs up, subscribing for more science tutorials, and hitting that notification bell so you don't miss our next video. Your support really helps us create more content like this. See you in the next one.